Before we get started, I want to let you know for the next several months, I'll be publishing videos every Tuesday and Thursday. And once that changes, I will publish another update. Let's get started. One of the most popular libraries in the R ecosystem is ggplot 2. And here on the homepage, you can see that using the R tidyverse packages, you can really easily create figures like this, where we're just creating a scatter plot called a g-on-point. But with a little bit of practice, you can see how we can begin layering more data onto this and creating quite sophisticated figures. Here's an example of layering. So we have our ggplot template, and then we're going to use g-on-point and g-on-smooth within the same figure. And because we can add multiple layers, you can see we created a figure with a trend line quite easily. And so because of this, Python has a solution called Plotnine that's supposed to be quite analogous to the grammar of graphics plotting demonstrated in ggplot 2. Now, Plotnine is based on Matplotlib, but it's definitely worth taking a look at because this grammar of graphics allows for a lot of flexibility. And then in the next video, I demonstrate how Seaborn also has options for a grammar of graphics style approach to data visualization. Here is the homepage for Plotnine. And as you see right at the header, they talk about a grammar of graphics for Python. And as you see, by importing Plotnine, it's actually calling ggplot. And we can take this Occam's quartet, use similar types of language such as g-on-point and AES for aesthetics, and create similar types of plots. If you look at here, you can see there's several different options that are quite nice for quickly creating publication-worthy figures. And this is similar to what you can do in R. So as a chemist, let's put some chemistry data into this and see what we can do quite quickly. If this is your first time hearing of Plotnine, you might need to install Plotnine. Now you can do that directly in your notebook environment by using the !pip install Plotnine, and you then could run the rest of this notebook. I have a data frame of near IR data, and I have melted it so that it is actually in a long format. And if I show you the first 5 rows, we see we have our spectrum ID, our wavelength, absorbance, and the material class. So this is part of a larger project I'm building on the project channel. And so let's demonstrate a basic Plotnine plot. I'm going to call that plot P1, and we're going to use syntax that looks kind of unfamiliar if you're in the Python environment. Because first we're going to use ggplot, which is typical, but then we're going to add additional layers using the plus sign. So we're going to create our base layer, this ggplot, with our df long data frame. And then we're going to use the wavelength and absorbance as part of our aesthetics. And we're going to instruct ggplot to consider the material class for color. Next, we're going to create a line plot with an opacity of 0.45 and a line size of 0.5. And then I'm also going to use a minimal theme. Next, you see we're going to add an additional layer called labs or labels. And we're going to just establish a title, label our X and Y axes, and then also apply some coloring. So I'm going to use a qualitative color map called palette 1, and then we're going to label that as material class. When we run the cell, you see it creates very nice figures. Now, there's several things here that are imported. So I want to go back to the beginning so that you can see one of the differences when we're using Plotnine versus something like Matplotlib or Seaborn. So one of the major differences when you're using Plotnine is that you have to import each individual component. So we have to import ggplot, aesthetics, geom-line, theme minimal, or any other thing you might want to use, as well as labs and scale color brewer. Now there are ways to import the entire library, but we sometimes don't want to do that in case we have an overlap with another library. So a lot of the layers you see here have been imported explicitly for this figure, and you're going to see additional imports as we move through this notebook. So let's take this plot and add some additional features to it. And let's begin by faceting by the material class. As I mentioned earlier, when you're using Plotnine, you have to import each individual component. So now we're going to use facet wrap. And if we want to do an additional theming, we also have to import that as well. So the line to pay attention to is actually line 8 here, where I'm going to facet by material class. And this is just one of the columns in that data frame. Otherwise, everything else should be the same. So the lumber class is shown here on the left in green, and the vinyl class is shown on the right in purple. We can also set n columns equal to 1. And when we do this, we will get a different facet where we have one column and 2 separate rows. But either way, you can see that this figure looks really good, and we could change other things like the theme, the scaling, the color map, And this is just part of what we can do with this grammar of graphics and the plot. Next, let's add some more details to this figure that's more chemistry specific. Let's highlight the lambda max or any other band we might want to in this data frame. To do that, we're going to create 4 new variables called lambda max and band, and then lambda max and band 2. And we're going to combine some traditional pandas methodologies with this Plotnine library. So essentially what I'm doing with lambda max is identifying a point, and then we're going to use band to create some additional range between these points. And now with that, in this cell, we're going to pay attention to line 11 and 12, where I'm adding 2 additional lines. And this is going to allow us to highlight multiple sections within our same plot. And what I want you to see is that although we're adding additional layers, the other parts of the figure stay exactly the same. And now the figure has rendered, you can see we have one band around 1720 and another band around 1900. And they're different colors or different widths. And this is one of the benefits because this is quite simple to implement, especially once you get comfortable with the Plotnine library. Next, let's add some additional theming. So let's see what we can do with this figure. And this library has the ability to use something called a common theme, which I think is actually really cool because if you have a style that you want to apply to everything in your publication, or if you're working for a company and you want to ensure that all the figures or data that comes out of this company is set to a specific color, you can do that by using something called a common theme. And again, to note, we have to import the theme class and the element text if you want to modify any of those components. And let's do that. So we're going to take our P1 that we had earlier, and we're just going to add common theme to it, and it's going to overlay the new theming to this figure. So we're going to do that. And you can see now the text is a little bit larger, it's a bit more bold, and we can add quite a bit of specificity with this common theme. So regardless of the figure, you can modify it. If you were to take common theme out, you can see the subtle differences between P1 plus P1 with the common theme added. Another cool feature of this library is that we can take our common theme and we can add an additional theme. Let's say we want to modify the figure size. And so we can rerun the cell now that the figure is much larger just by adding an additional theme component. Lastly, let's apply some statistics to these figures. And as you've seen earlier, adding additional layers is quite simple. So I want to demonstrate this in 2 steps. The first figure we're going to call p_mean, and we're going to create our same ggplot base layer. And then we're going to add a layer called stat summary, where we're going to apply the numpy mean function to our data and output as a line. So this is going to aggregate based on our material class, and then we're going to apply our minimal theme and then display that figure. Now you see the output, instead of having multiple lines for each of our material classes, we have a single line that represents the aggregate or the mean for those 2 different classes. Lastly, let's take this one step further and now apply a confidence interval to this data. So rather than just outputting the mean, let's output the mean plus a confidence band across the line plot. To do that, I'm going to create 2 helper functions called CI low and CI high, and we're going to compute the standard error for those 2 values and then apply them to our figure. We're going to add a couple of additional components. So we're going to use the fill. Of course, we saw group earlier. And then I'm going to apply the function ymin and function ymax to our stat summary, as well as the geom ribbon argument. As you see with the import, we've also included stat summary for this particular figure as well. And that's what's allowing us to create this particular figure. When we do this, you see that we have our 2 lines from before, but if you squint very closely, you'll see we have an error band on these 2 figures. And this is really just the tip of the iceberg with this particular library. So I haven't spent much time exploring it, but it did get me really excited about a library that Seaborn has called Seaborn Objects, which applies a lot of the grammar of graphics, but in a more Pythonic way. So if you enjoyed this video, like, comment, subscribe, and let me know if you've used this library or if there's other libraries that you feel might be underutilized or unappreciated that I should go over in this channel. In any case, if you enjoyed the video, like, comment, subscribe, and I'll see you in the next one. Peace.